Are going to want calculators today because we are definitely graphing quite a bit of these. So I'm going to show you guys a couple of different methods, and honestly it kind of makes sense to test it in the calculator through graphing, and then how do we go through and do it through algebra. So it tends to make life a little easier. Alright, so it says we need to solve this inequality. And we're going to do it by graphing the original function. However, what does it mean when I say x plus 3 times the quantity x minus 1 squared is greater than 0? Is greater than 0. So we're essentially looking for where is this above the x-axis. Okay? So anytime it's greater than 0, I'm just looking to see where does it end up being above my x-axis. Alright, so shall we enter this thing on the right to the calculator and hit graph? Alright, so do we see something kind of like this? Okay, so where am I above the x-axis? Alright, so negative 3 to 1, except what happens at 1? But what does the y equal? It equals 0. So this is where crap gets a little funky, because I said it has to be greater than 0, right? Not equal to 0, greater than 0. So, when I'm looking at this, I've got between negative 3 to positive 1, right? That's above, but when it hits 1, it hits 0 for the y, yes? So then I have to go from 1 to infinity. So if we're writing it in interval notation, I go from negative 3 to 1, but not inclusive, because it's got to be greater than 0, not equal to 0. Then I have to keep going from 1 to infinity. Do we want to see it in set builder as well? Okay. So set builder would look like x such that we're going to say x is greater than negative 3, but not equal to 1. Alright, so everything from negative 3 on up, but the point 1 is where we hit 0. That causes bad things, so I can take that out. Yep. I'll put on there which notation I want it in. For the most part, and if I don't, I don't. I'm fine with either. Okay? Ready to keep going? All right, so next one is, how can I solve this problem algebraically? Ready? So, how many of you want to divide by x right away? Okay, don't do that. So, and I tell you that because that was always my thing, like, everything divide by x. So here's the problem with this. If I divide by x, and if x equals 0, what happens? Can't divide by 0. Bad things happen. So, I would put a little note on the side, like, do not divide by x, because x could equal 0. Okie dokie. So that's going to be kind of the biggest issue with it. So, we're going to do it the old-fashioned way. Move all the x's to one side. So that gives me x to the 4th minus x is now greater than 0. And then can I factor that? Yes, I can pull an x out, so I've got x cubed minus 1 is greater than 0. Can I factor that x cubed minus 1? Yes, that is sum or difference of cubes, which a lot of people have forgotten that that's like a thing. Yeah, so it's x minus 1 and then x squared plus x plus 1 is greater than 0. Kind of, sort of. Are you guys just trusting me on that with the factoring? Okay. If you're not sure about how to factor those, just Google sum or difference of cubes formula. Like, literally, you can pull up a Google image and just write the formula in. Easy peasy. So, if I were to actually go through and solve this, this would give me a 0 at 0, yes? Right? This would give me a 0 at 1. Now, what happens with that x squared portion of it? Do we remember? So sum and difference of cubes, you've got 1 real, 2 imaginary. So this right here is going to create your imaginary solutions. Okay? So let's do this. Let's graph it, and we can take a peek at it and see kind of what we're thinking, and then how we can kind of get us back to something that's a little workable algebraically. And, because I had first period, so what are we noticing? Yeah, this little dip between 0 and 1, hey, we kind of mentioned those. That's where it becomes negative. So I'm looking for everything that's not between 0 and 1. All right? So once you start getting really good at these, you'll start noticing, like, okay, I've got a 0, I've got a 1. If I think about what this would look like graphically, I've got 0, I've got 1, and then it's got to go up like this, yes? Remember all that end behavior leading coefficient crap? That's where this kind of comes in handy. So between 0 and 1, that's where I have an issue. So if we're doing it on interval notation, that would be from negative infinity to 0, and then from 1 to positive infinity. Do we want to see it with step builder as well? Yeah. You got to look on your face like, what magic did you do? You good? Okay. It's just Tuesday tiredness? Okay. It is Tuesday. It's not Monday anymore, though.
Yeah, but then it's Tuesday.
All right, so I need every x that is less than 0, and I need every x that is greater than 1. So that's how I would write that. What do we think? Okay? Keep going? All right. So for this one, we're going to find the domain. I got my mic caught. All right, ready? So what do we remember about finding domain with a square root function? Okay, we have to set what's underneath equal to 0. I really selected red, but whatever. What else? It has to be positive. So it's got to be basically greater than or equal to 0. So that would give me everything that's positive as well. Because I can take the square root of the 0, I can take the square root of 1. It's when we start getting into imaginaries that we can't do that on a graph. So I'm going to set the inside to be greater than or equal to 0. Any ideas? Yeah, factor out an x squared. Any other ideas? So 3 is where it equals 0, right? So when x equals 3, it's equal to 0. And then when this one is 0, then it is equal to 0 as well. Yes? Now the problem becomes, where is it greater than 0? So let's pick 1. If I plug 1 in, what do I end up getting? So if I plug in 1, negative 2. So that gives me negative 2. That is not greater than 0, so sad face. All right. I'm guessing the same thing's going to happen if I plug in 2, right? Because 2 minus 3 is still going to give me a negative. What about picking 4? So it's still positive though, right? That's a happy face. Could I go less than 0 and check those? Maybe I could. So what if I plug in negative 1? What do I get? Do I get a positive or do I get a negative? A negative, so that's a sad face. All right. So for this one, it's a cubic, yes. Think parent functions, or like how it should generically look. I'm going to erase some of this. It's a cubic, positive leading coefficient, so it's got to kind of look like this, right? Yes? Now, I've got a point at 0, 0 where it equals 0. Then I've got another point at 3 where it starts to equal 0 again. Does that make sense? And if you think in terms of how this should actually be graphed, I know it's just touching my x-axis at 0, right? So I've got a touch at 0, and I've got a cross at 3. So without even plugging this into the graphing calculator, can I figure out the interval for my solutions? Yeah. So this is where you use all of that polynomial knowledge. Like, okay, yeah, you could sit there and plug it into the calculator, but you may not necessarily have time for that. So from here, in interval notation, I've got 0, and then I've got everything from 3 on up. And we're going to include that 3, because 3 is where it equals 0 again. Do we want to do it in set builder notation? Yes. Squiggly x such that x equals 0 and x is greater than or equal to 3. Not quite as bad as we were expecting it to be. No? All right. Let's get this crap over with. Yes. Yeah. So I just say we keep going with it. What you got over there? Yeah, it's definitely something based on the giggles and the blushing.
Why is it raccoon playing?
Because it's a Tuesday, so why not having a raccoon playing a saxophone?
Band kids.
Band kids is exactly it. All right, we got this written down? Yes? No? Ready? Okay, so this one's going to be a little difficult because I either have to graph it and figure it out, or I'm going to have to use what I know about rational functions so I can kind of figure out how it should look. Okay? So I'm trying to figure out where it's greater than 0, except what kinds of things do I know about this? X can't be 2, or negative 2. So this one's at -2, this one's at +2. All right. And what happens if I plug in 1? It's going to give me 0. So I've got a problem at 1 as well. All right, so when x equals 1 equals 0, and that is sad. Okay? What happens if I plug in 0 to this? What do I get? No. Okay. So 0, I get 1/4. That makes me happy because it's positive. What happens if I plug in, yeah, let's check 3. I was going to say let's check -1. 3 is 2/5. That's still positive. What about -1? What do I get when I plug that in? Got -2 on top and then -3 on the bottom, so that's 2/3. Also okay. What happens if I plug in a +3? Oh yeah, we already did that one. Okay. What about -3? It's a negative. -4/3. So that's a frowny face. So by doing this, I'm kind of able to see where am I above or below the x-axis. So if we're graphing this, more than likely I've got a chunk down here. And then I've probably also got a chunk like this kind of coming down. And then because +3 is positive, when we plug it in, I'm probably up there. Does that kind of make sense? Anybody doubt me on that? I was going to say, we can graph it. All right, so for interval notation, I've got between -2 and +1 parentheses, because I can't hit -2 because it's an asymptote, and I can't hit 1 because that makes it equal 0, and that's bad juju. And then I've got everything greater than 2 on the opposite side. And then if I graph the stupid thing, not that one. I'm not cheating. I do have it plugged in. I'm prepared. And I did it first period. So that helps. What do we think? Kind of snazzy? Like, as a method of doing it, like, you can kind of guess numbers and pick it out from there. Haley? Oh my god, Haley. Matt. What do you mean? No, so there's an x-intercept at 1. Right? Because anything that makes the numerator equal 0, those are x-intercepts. So the problem we run into at 1 is it equals 0. I need it to be greater than 0. Okay. All right. Set builder, I don't feel like writing on this one. Onward? Yes? No? Kind of? All right. This one we can solve completely through algebraically because it doesn't involve a 0. Or at least not yet. All right, any initial guesses on this one, how we would go through and solve it algebraically? Okay, factoring, that's going to be part of it. So I'm going to give you a hint first. Treat this like a proportion. I'm going to multiply that x plus 2 quantity squared up to the right-hand side. Then I'm only dealing with one lovely little line of nastiness. Now, as much as this is going to suck, you do need to FOIL out that right-hand side. distribute that 3 in. Now my recommendation is to move everything with an x to the left. Move everything that's just a number to the right. And here's a reason why I recommend doing that. When I subtract off this 3x squared right here, those cancel. When I do it over here, these cancel. Nice. Move my 12x, move my 12x, that gives me a 1. Move my 9. So I end up with x is less than or equal to 3. Ta-da! We're done. You're like, what monstrosity did you just do, lady? So when I move the 3x squared over, those canceled. That's nice. Move the 12, and I'm left with 13 minus 12, and that just gives me a single x. But because I need the numbers all on the same side, I moved the 9 to the right, and this is what I'm left with. Not as bad as we were expecting it to be. Easiest thing so far. Like, all right, give me the algebra. I can do that. All right. I think I've got 2 more examples. I've got this one where we find the domain. Actually, I've got 3. Do we want to do another one where we find the domain? You want to try that part on your own? Okay. We get stuck. So what I did was I went through and I said I know I have a vertical asymptote at x equals -4. And then I know I have a y-intercept at x is +1. Right? So what happens if I plug in 0? Do I get a positive or a negative? -1/4. So this side of the graph actually goes like this. What happens if I plug in a -5? What do I get? So I got -6 on top, -1 at the bottom, so that gives me a +6. So that's going like that. Okay? So if we're looking for interval notation, I've got -∞ through -4. And then I've got from 1 to +∞. Any doubts? Did anybody graph it? I have it graphed. Hang on. Turn you on. Pretty snazzy, huh? So literally all you're doing is you're trying to get just a generic sketch for the graph so you can figure out where it's going to be greater than 0. All right. Do we want to try solving this one algebraically? Okay. Let me get people a minute so they can write this down and get it started. Anybody get stuck? So there's 2 different ways of solving this. Do you guys want me to just write both of them up? Sure. So for me to get this with a common denominator, I need it to be over x, so I have to multiply it by x over x. Because x squared divided by x cancels down to just plain old x. What am I doing right there? The other way gets you to this table as well. Do you guys just want me to write the table? Or how you solve it that way? Up? Yeah. So the other way to solve it is moving the x over. That's what you did. So I've got, I'm going to do this one in x plus 12. Why am I putting an equals to? And then you get down to the same part, but at least it's just a different solving method. All right, so let's pick some points. I know if I plug in 4, that's going to equal 0, and that's not going to work here. What happens if I plug in 5? 5 minus 4 is 1, 5 minus 3 is 2, so I get 2. That is not less than 0 either. What happens if I plug in, well, we said 3 gives us 0, that's no good either. 2. 2 minus 4 is negative 2, 2 minus 3 is negative 1, so negative 2 times negative 1 should be 2. Ooh, that also causes a problem. All right, and if I go bigger than that, or I'm sorry, not bigger than that. If I go down further, like 1, 0, any of those, I'm still going to be positive. That creates a problem. I think it's actually between 3 and 4, if I remember correctly. So, if I graph it, do I have this one in here? Oh, I might actually not have this one typed. Oh, can't cheat. So I've got x minus 4, x minus 3. Graph it. So could there have been another way to look at this, like knowing that it's a quadratic and I know I have zeros at 4 and 3? All right, so using your end behavior, I know I got zeros somewhere. I need to scroll, hang on. Oh, crap on a cracker. So, end behavior, I know I've got a 0 at 3. I know I've got another one at 4. It has to be, like, facing up like this, right? Because my leading coefficient's positive. Only way this is going to work is if I just dip below the x-axis between 3 and 4. All right, so literally your answer for this one is just 3 parentheses 4. It's whatever answers you can get between 3 and 4. And I didn't forget to write you in subbuilder. Does that make a little bit of sense? Still kind of funky? Who likes cookies? All right, now I got people paying attention. All right, cool. So I'm going to pass out the stickers that have the last word problem, and I'm going to write your thing with set builder. You guys have some stickers. You're going to need some. I know, but they just got 6 more. So that'll be able to pass back. All right. It is a pizza one.
Okay, and then there's salt.
You're basically looking for an interval where you meet certain criteria. Where is it negative? Where is it positive? We're being really sneaky and trying to give you info for calculus without telling you about calculus. That's how I would write that one. All right. Ready for the word problem? Did everyone get a sticker? Okay. So, you have decided that on the weekends, you're going to start making pizza to make some extra dough. It's a pun. This is Lou did it. And I looked at it and I was like, I'm leaving the pun, because why not? All right, suppose your cost function is 2x plus 15, and x is the number of pizzas you make each day, so therefore the average cost per pizza would be made by that formula. How many pizzas do you need to make so the average cost is no more than $3? So could I take the part for the average for my cost of pizza? I want it to be no more than 3. So how would I write that? Less than or equal to 3. I can hit 3, but I don't want it to be more than $3. Can we solve this? Well, you're trying to minimize your costs. So how much it's going to cost for you to get the stuff to make the dough, your time, all that stuff. Can we solve this from here? Yep. Yep, multiply both sides by x. Yep, move that 2x. So 15 is less than or equal to x. Let's flip that around. X has to be greater than or equal to 15. So I need to make at least 15 pizzas. Does that seem worth it? It's a lot of pizza to make. Who does? Pizza businesses? Oh, yeah. Yeah, just make a DiGiorno. Honestly, I don't know why we don't do like Little Caesars pizza kits for fundraising, because I would buy the crap out of those.